In this video I would like to talk a little bit about electrostatics, which is a branch of electricity and magnetism, which deals with the condition that the charges are stationary. It is a must because things get quite different when charges tend to move. So just to remind you some common sense type of things. If I have two charges which let's say this is a positive charge and this is also a positive charge, then we all know and we all have studied it. You might also have experienced it sometimes in the form of magnets, maybe. If these two are the north poles, even if these two are south poles, then they tend to repel each other. Now if north repels, then south also repels, you know that. So its equivalent in electrostatics would be that if positive charges repel each other, then negative charges should also repel each other, and then that's truly that is indeed the case. So if I also have some negative charge on both of them, then they also repel each other. That is also very understandable, very intuitive. So they repel each other. Okay. Now another key observation made is that if I have two charges which are opposite in polarity, which implies that if one is positive then the other is negative, then things change a bit. They do attract each other, and that is also very reasonable, and we all have seen that again in the form of magnets. We know that south pole and north pole attract each other, right? Now physicists, I believe that is correct, yeah. Physicists actually don't really worry about the direction of the force, but they also want the magnitude of the force, right? It is not very useful to know just the direction, but to also know the magnitude. Then you are talking, right? So there is something called the Coulomb's law, and Coulomb's law is an experimental law, which implies that it was derived using experiments. So if I call the force F, the magnitude of that I call F, and let's say I call this distance between the charges R, then through experiments it was found that the magnitude of that force F is proportional to the product of the charges. If I call this Q1 and this Q2, not assuming that both are positive, they can be anything, it is proportional to the product of the charges. And it was also found that that same force is proportional to the inverse, or you can say inversely proportional to the square of the distance between them. So we can combine these two equations to write that force is proportional to Q1 Q2 over R squared. Now we can remove the constant of proportionality. We can remove the proportionality to write that F is equal to some constant times Q1 Q2 over R squared, and this is called Coulomb's law. This is called Coulomb's law. Forgive me for my handwriting, I can't help it. So this is purely experimental, and yeah, and the value of that constant k there is also found out through experiments, and it is found to be 9 times 10 to the ninth. That is the magnitude of that of that constant. This is also written sometimes as 1 over 4 pi epsilon 0. Okay, so yeah, this is the Coulomb's law, and we can further massage this, and I'll do that in the next video. So this was an introduction to electrostatics. So I hope you like it, and I'll see you in the next video, where I'll do a few more advanced things and do some problems based on Coulomb's law.